9,
It was a bitter cold but sparkling clear morning at Cape Canaveral. Here at the last seconds of the countdown.
3, 2, 1, and liftoff. Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
All the communications between the shuttle and mission control indicated everything was going fine. There was a sense of relief that the much-delayed flight was finally underway.
Engines at 65%, 3 engines running normally, 3 good fuel cells, 3 good APUs. Engines throttling up, 3 engines now at 104%.
Challenger, go at throttle up.
Roger, go at throttle up.
It happened just over 1 minute into flight.
1 minute, 15 seconds. Velocity 2,900 feet per second. Altitude 9 nautical miles. Downrange distance 7 nautical miles.
From mission control, silence. Then the bland, chilling report.
It was supposed to be routine, a launch like many before it, a moment of progress. Instead, it became something else. On January 28th, 1986, millions of people were watching. Classrooms across the United States had televisions turned on. Students sat at their desks, waiting, because this launch was different. For the first time, a civilian was going to space. Her name was Christa McAuliffe, a teacher, chosen to represent something bigger, education, inspiration, the future. The spacecraft was the Space Shuttle Challenger, and the mission was expected to be uneventful. But long before the launch, there were concerns, quiet ones, technical, not visible to the public. Engineers had been studying a component called an O-ring, a small seal within the solid rocket boosters. Its job was simple, prevent hot gases from escaping, but it had a weakness, cold temperatures. In low temperatures, the material became less flexible, less reliable, and on the morning of the launch, it was unusually cold, far colder than previous launches. Ice had formed on parts of the launch pad. Some engineers raised concerns. They recommended delaying the launch until conditions improved, because they didn't know for certain if the O-rings would function properly in the cold, but uncertainty was not enough. There were pressures, schedules, expectations. The decision was made. The launch would proceed at 11:38 a.m. The engines ignited, flames erupted, and the shuttle lifted off. For the first few seconds, everything appeared normal. The ascent continued. The shuttle climbed higher, faster, until, just over a minute into the flight, something changed. A small plume of smoke had been visible near one of the boosters shortly after liftoff. It was brief, easily overlooked, but it indicated something had already gone wrong. The O-ring had not sealed properly. Hot gases began to escape. At first, the leak was partially sealed by residue, but as the shuttle ascended, conditions changed. Pressure increased, the seal failed, and a flame began to burn through the structure. It reached the external fuel tank, containing liquid hydrogen and oxygen, highly volatile. At 73 seconds into the flight, the shuttle disintegrated. Not a single explosion, but a rapid structural failure. Captured on live television, millions watched it happen. Confusion followed. At first, many didn't understand what they were seeing. The smoke, the debris. It didn't look like a typical explosion. But the reality was clear. The mission had failed. All 7 crew members were lost, including Christa McAuliffe. The shock was immediate, because this wasn't just a technical failure. It was public, broadcast live, watched by children, by families, by an entire nation. In the aftermath, questions began. How could something like this happen? What went wrong? An investigation was launched. The Rogers Commission. Their goal was to find the cause. But as they dug deeper, the story became more complex, because the issue with the O-rings was not new. It had been observed before. In previous launches, there were warning signs, data points, concerns raised by engineers. but they had not led to action. The problem had been accepted, normalized, seen as a manageable risk, until it wasn't. One demonstration during the investigation became widely known, a simple test, an O-ring placed in cold water, then compressed. It failed to return to its original shape quickly. A clear visual of the problem, simple but critical. The findings were clear. The disaster was caused by the failure of the O-ring seal, exacerbated by the cold temperature. But the deeper issue was organizational, decision-making, communication breakdowns, warnings not fully acknowledged, concerns overridden. It wasn't just a technical failure, it was a systemic one. After the investigation, changes were made, designs improved, processes revised, but the event remained a turning point because it showed something important, that even in highly advanced systems, small details matter, and ignoring them can have irreversible consequences. Today, the Space Shuttle Challenger disaster is remembered not just for what happened, but for why it happened, a combination of factors. Technical, human, organizational, all aligning at a single moment for 73 seconds. Everything seemed fine, and then it wasn't. A mission that was meant to inspire became a reminder that progress comes with risk, and that sometimes the warning signs are there long before the moment itself.